Our lesson for today is about remainder theorem. Our objectives: prove the remainder theorem, determine the remainder when a polynomial p of x is divided by x minus c. Find some unknown variable when p of x is divided by x minus c if the remainder is given. Remainder theorem. Let p be a polynomial function. If p of x is divided by x minus c, then the remainder is r is equal to p of c. Determine the remainder when p of x is divided by the second x minus c. P of x is equal to 4x cubed minus 3x squared plus x minus 5. Now our first step is to equate x minus c equal to 0. X plus 1 is equal to 0, therefore x is equal to negative 1. Use substitution or synthetic division. Then step number 3, get the remainder. Determine the remainder when the first expression is divided by the second. Our divisor is equal to x plus 1. We have to equate that to 0. X plus 1 is equal to 0, therefore x is equal to negative 1. Copy the numerical coefficient: 4, negative 3, 1, negative 5. Bring down the leading numerical coefficient: 4. 4 times negative 1, negative 4. Negative 3 plus negative 4, negative 7. Negative 7 times negative 1, positive 7. 1 plus 7, 8. 8 times negative 1, negative 8. Negative 5 plus negative 8, negative 13. And that is the remainder. Determine the remainder when the first expression is divided by the second. P of x is equal to 4x cubed minus 3x squared plus x minus 5. Our divisor is equal to x plus 1. We have to equate x plus 1 equal to 0, therefore x is equal to negative 1. Copy the numerical coefficients of 4x cubed minus 3x squared plus x minus 5. 4, negative 3, 1, negative 5. Bring down the leading numerical coefficient 4, then multiply that by negative 1. 4 times negative 1 is equal to negative 4. Negative 3 plus negative 4 is equal to negative 7. Negative 7 times negative 1 is equal to positive 7. 1 plus 7 is equal to 8. 8 times negative 1 is equal to negative 8. Negative 5 plus negative 8 is equal to negative 13. That's the remainder. Now, using our second solution, we can use p of negative 1. P of negative 1 is equal to 4 times negative 1 raised to 3 minus 3 times the quantity negative 1 squared minus 1 minus 5, and the same remainder, negative 13. Therefore, we can say that if p of x is divided by x minus c, the remainder is r is equal to p of c. Determine the remainder when the first expression is divided by the second. Equate x minus 3 equal to 0. Therefore, x is equal to 3. Now we're going to use synthetic division. Copy the leading numerical coefficient to negative 5. There's a missing degree, so we have to use 0. 1, and negative 2. Bring down the leading numerical coefficient 2. Multiply that by 3. We have 6. Negative 5 plus 6, positive 1. 1 times 3, 3. 0 plus 3, 3. 3 times 3, 9. 1 plus 9, 10. 10 times 3, 30. Add negative 2, positive 30, you have 28. And that is the remainder. Determine the remainder when the first expression is divided by the second. Our divisor is equal to x minus 1. We have to equate that equal to 1. On this type of problem, it's not advisable to use the synthetic division. We have so many remaining degree. Instead, we're going to use the substitution, P of 1. P of 1, if x equal to 1, 1 raised to 20 minus 1 raised to 2019. That's equal to 1 minus 1 is equal to 0. Therefore, the remainder is 0. Sometimes, you will encounter a problem with missing value. Determine the value of k when kx cubed minus 7x squared plus 2x plus 30 is divided by x minus 2 and the remainder is 22. Determine the value of k when kx cubed minus 7x squared plus 2x plus 30 is divided by x minus 2 and the remainder is 22. Equate x minus c is equal to 0. X minus 2 is equal to 0, therefore x is equal to 2. We're going to solve k times 2 cubed minus 7 times 2 squared plus 2 times 2 plus 30 is equal to 22. 2 cubed is equal to 8. Therefore, we have 8k minus 7 times 4 is equal to 28 plus 4 plus 30 is equal to 22. Now we can simplify this. We have 34 and negative 28. Therefore, we have 8k negative 28 positive 34. So we have positive 6 is equal to 22. 8k is equal to, we can add negative 6 on the left side and the right side. 16. Therefore, k is equal to 2. When x cubed minus 6x squared minus 7x plus k is divided by x minus 1, the remainder is 5. Solve for k. Equate x minus 1 equals 0. Therefore, x is equal to 1. Copy the numerical coefficient 1, negative 6, negative 7, k. Bring down the leading numerical coefficient 1, 1 times 1, 1, negative 6 plus 1, negative 5, negative 5 times 1, negative 5, negative 7 plus negative 5, negative 12, negative 12 times 1, negative 12, and the remainder must be equal to 5. You have to equate k plus negative 12 is equal to 5. Adding 12 on both sides, k is equal to 5 plus 12. Therefore, k is equal to 17. Exercises. You're going to answer 10 items. Pause the video when answering. Determine the value of k. We have the following answers. Number 1, r is equal to 0. 2, r is equal to 7. 3, r is equal to 0. 4, r is equal to 21. 5, r is equal to negative 7. 6, k is equal to 6. 7, k is equal to 13. 8, k is equal to 16. 9, k is equal to 1. 10, k is equal to 40. If you got 8 to 10 correct answer, excellent. If you got 6 to 7, good. You got 5, passing mark. If your score is less than 5, watch the video again and repeat the exercises which you got wrong. For the proof, P of x is equal to Q of x times D of x plus R. If D of x is equal to x minus c, P of x is equal to Q of x times x minus c plus R. Evaluate P of x when x is equal to c. We got that when we equate x minus c is equal to 0. Therefore, x is equal to c. P of x is equal to Q of x times x minus c plus R. Use x is equal to c. P of c is equal to Q of x times c minus c plus R. P of c is equal to 0 plus R. Now we can say, if a polynomial P of x is divided by x minus c, then the remainder is R is equal to P of c. On this lesson, you learned how to prove the remainder theorem. Number 2, determine the remainder when a polynomial P of x is divided by x minus c. And number 3, find some unknown variable when P of x is divided by x minus c, if the remainder is given. Thank you for watching.